Hello? Hello? Okay, we are now live. I am checking from my mobile also. First of all, to know whether you are getting my voice or not, please confirm. Confirm in the comment section. Are you listening to me? So that we can move forward. Hello? Are you listening? Please comment. Hello? We'll wait for 5 minutes and then we will start our lecture. Please comment. Okay, some has cleared audible. Okay, first of all, you should comment where from you are, from which country you are listening, so that I know from where our viewers are, where from our viewers are. So please comment. from India. Mr. Dime Methi from India. I am also from India. House, Texas. Roddy Habede. Okay, okay. West Bengal, India. This is the okay. Brother, I am also from India, but from Kashmir. How many of you know me? Are you aware of me? Andhra Pradesh, India. Okay. Motivate to yourself. Someone is Andhra Pradesh, India. Who know me first of all? Did anyone know me before this lecture? If you know me, then you can put yes so that I can give introduction to myself, who I am and where from I am. Power system analysis, West Bengal. Okay. My name is Pawan sir, and for your question, I am first time for your class. Okay, no problem. Your first time. Are you joining my WhatsApp group? Are you my Mr. Pawan? Mr. Pawan, are you my group member of my WhatsApp? I will share the WhatsApp link. 1 minute. I will share my WhatsApp link, or you can get my WhatsApp link from where you can get my WhatsApp link. Okay, I will share later on. No problem. Okay, I think we have to now start. Leave. Others may join. First of all, our lecture is effect of X by R ratio on short circuit current. In this lecture, we will calculate the X by R ratio of short circuit current and see the effect of the X by R ratio on the short circuit current. We can verify our results through ETAB and Silent Power Factory. There are two software which are used for power system analysis, ETAB and Silent. Whatever the calculation we do manually, we can verify their results from ETAB and Silent. Okay. My name is Ejazul Haq. I am from Jammu and Kashmir, mainly from Kashmir division, India. I have done my BTech in Jammu University and MTech in Kurukshetra University. I had total 12 years of experience in substation design, transmission, and almost 2 years of experience in power system analysis. So, in today's lecture, our contents of the lecture are: what is short circuit, AC and DC components of the short circuit current, where from DC component come in short circuit, time constant, percentage DC component, 1 minute, percentage DC component, X by R calculation for 50 Hz and 60 Hz system. X by R ratio is different for 50 Hz and 60 Hz because it depends also on the frequency. So 50 Hz and 60 Hz, they are different frequencies and their X by R ratio is different. Manual calculation for peak value of short circuit current. Verifying the calculation of peak value of short circuit current using ETAB software and Dixon Power Factory. You know that our X by R ratio affects on the peak value of the current. It does not affect our RMS value. It affects on the peak value of current. Then finally, we have question and answer session. If you have any question, you can ask at end. During lecture, you cannot ask it because it will disrupt the flow. So at the end, you can ask whatever the questions you have, or you can post the questions through LinkedIn or in this video on YouTube. I can take later on whatever you feel suitable for you. First of all, we will see what is short circuit current. A short circuit is an abnormal condition where current flows through an unintended low resistance path due to a fault. This causes a sudden surge in current, potentially damaging equipment. To prevent the damage due to the short circuit or overload of the system, we use protective device called circuit breakers. Choose a circuit breaker involves examining the X by R ratio to ensure it handles the fault current effectively, protecting the system and equipment. Actually, short circuit, what is short circuit? Short circuit, if we ask someone to what is short circuit, they will say it is a flow of current through flow of current through a low resistance path. But it is not a complete definition. Actually, it is an abnormal condition which flow. This is a flow of current, but not through for low resistance, but for unintended path. The path through which I do not want to follow the current. The short circuit current is flowing through this. If suppose phase to ground fault, current is flowing from phase to ground. We do not want the current should go for phase to ground. This is the unintended path. What is the effect of the short circuit current? The effect of sorry, Mr. What is why only affect RMS peak value? I will answer that. You can in coming slides you can get answer of that question. I will first of all close. I will take later on these chats. To prevent the damage, what happens in the short circuit? In the short circuit, when the short circuit occurs, there is a very huge rise in the current. There is a huge surge in the current. This will damage our equipment. To prevent the damage of our equipment due to this huge surge current, we are using protective devices like circuit breaker mainly. And to choose the circuit breaker, for that we should examine the X by R ratio. That means our X by R ratio affects the choice of our circuit breaker. We can see later on in the coming slides how the X by R ratio affects the selection of the circuit breaker. You can see the AC and this is a AC fault current. When the fault occurs, our short circuit current has two components. One is AC component and another is DC component. You can see this is the DC component. This is the DC component I have mentioned here. The DC component, till the DC component is present in the short circuit current, our short circuit current is asymmetrical for that portion. You have studied in your BTech course that this about this figure. This portion up to this point, I will take a 1 minute. I will take it up to this point. Our short circuit current is asymmetrical. That is not symmetrical about the time axis. And after that, it is symmetrical. You can see this is after symmetrically. You can see here the portion of this portion and this portion is not equal. That means it is asymmetrical. And after that, when the DC component decays, generally the DC component decays after 3 to 5 cycles. After that, our short circuit current becomes symmetrical. Now, where from this DC component came? The question is that where from this DC component came? In power system, the transmission lines have resistance, inductance, and capacitance. The inductance and capacitance are generally energy storing elements that store energy during normal operations. I will show you a transmission line model. This is a transmission line model you have studied in your BTech or master's course. It contains a capacitance and inductance and resistance. The resistance dissipates our energy in the form of heat. It converts the electrical energy into heat energy. But the capacitance and inductor, they store the energy. They do not dissipate, they store the energy. And when the short circuit occurs, they release this energy linearly, they not sinusoidally, they releases energy linearly. What we have also written here, whenever a short circuit occurs, the stored energy in these inductive and capacitive elements is released linearly, not sinusoidally. This unidirectional energy release gives rise to the DC offset in the fault current. That is we call it the DC component comes from these energy storing elements. The DC component makes the initial fault current asymmetrical. What I have already said you. After some time, this DC component decreases, leaving behind the symmetrical AC fault current. The rate of the decay of the DC component depends on the X by R ratio. The higher X by R ratio causes a slower decay of the DC component and vice versa. The DC component does not affect the RMS value, but it does affect the peak value of the fault current. And important consideration when designing protective system and selecting the equipment rating. Okay. AC and DC component of a short circuit current. The DC component generally decays within 2 to 3 cycles, but I have already told you that within 2 to 3 cycles, our DC component gets vanished. After that, our fault current becomes asymmetrical, and before that, it was just asymmetrical. After the decay of DC component, the short circuit current becomes symmetrical. IDC is equal to IDC e raised power minus T divided by tau. Tau here, tau is the time constant. Time constant is the time taken by the DC component to decay 37% of the initial value, and T, where T is the time taken by the breaker to clear the fault. Whenever we design any protective system or any system, we take the worst case. So I have also considered here the worst case, that if the fault occurs at 0 voltage crossing, at the 0 voltage crossing, our current will be maximum. So IDC, it is IDC T. It is not initial IDC T here. Okay, it is IDC T equals root 2 I symmetrical e raised power minus T by tau. IDC initial here is I peak value. Peak value is when, because when the as voltage crossing, at 0 voltage crossing, our current will be maximum. ISM, that's asymmetrical value. This is the RMS value. When we multiply the RMS value with the root 2, we get the peak value. Now, represent the IDCT percentage of a symmetrical component called in terms of percentage. We can represent this equation in terms of percentage of symmetrical component. That is called the percentage DC component. The percentage DC component is 100 root 2 e raised power minus T by tau. Okay. Applying now, we will apply both sides on log. That tau is equal, that is the time constant, is equal to T divided by ln of 100 root T divided by a percentage of DC. When you apply the log on both sides up to this equation, you will get this equation. Now we have got the tau to equal to this equation. Tau is also equal to L by R. Standard time constant is 45 milliseconds. While from this I have taken that the standard time constant is 45 milliseconds. It is as per IEC 62271-100. You can see, I will show you, this is the screenshot taken from that. The standard DC time constant is 45 milliseconds. The following are the special case DC time constant. There are other constants also, 120 millisecond, 60 millisecond, 75 milliseconds, but DC standard typical constant is 45 milliseconds. Almost 90% cases we have a time constant 45 milliseconds. But other time constants are also available 120, 60, 27. They are in special cases. So I have taken the 45 millisecond, which is a standard time constant. Tau is equal to L by R, that is the tau is the time constant, and it is equal to 45 milliseconds. X by R is equal to omega L divided by R. L by R is time constant, so we will write omega tau. Omega is equal to 2 pi f. Now for 50 hertz, putting f 50 for the f, you can solve this equation. Omega is equal to pi f. When we put 50 for f, you will get this value 314.16. So X by R, that is equal to tau by omega by tau. that is omega is this value, and tau is our 40 milliseconds. When we multiply this, you will get 14.14. For similarly for 60 hertz, you will get x by r ratio 17. I have told you an early slides that our x by r ratio depends on the frequency, and there is different value for 50 hertz and different value for 60 hertz. Okay. Now, we will do manual calculation of peak value. We know the initial peak value is equal to IP is equal to root T I symmetrical by K. This equation is given by IEC 60909 dash. IK double dash the initial symmetrical current. Initial symmetrical current usually mentioned is a breaking current of the circuit breaker. Suppose we will say that our circuit breaker has 25 kilo amperes of breaking current. This is actually the initial symmetrical current. This is the symmetrical current mentioned there. K is the constant and its value depends on the x by r ratio by this formula. K is equal to 1.02 plus 0.98 e raised power minus 3 by x by r. For 50 hertz, K is equal to, you can put for 50 hertz what is the value of x by r ratio 14.14. You can put here x by r ratio value, and you will get for 50 hertz K is equal to 1.81. And similarly for 60 hertz you will get K is equal to 1.84. For 60 hertz, you have to put the x by r ratio 17 in this equation. Now consider IK is equal to 25 kiloamperes. We will consider the 25 kiloamperes of the initial symmetrical current, fault current. For 50 hertz, it becomes 63.99. You can put C by putting this equation. Root 2 IK double dash is 25 and K is for 50 is 1.81. You will get 1.81 into root 2 into 25. You can get 63.99 kiloamperes. And for 60 hertz, IP is equal to root 2 I same equation, but you have to put only the value of here K value will change, others will remain same, and you will get 65.05 kiloamperes. Okay. Now one more thing I will show you in as per the ICT selection of short circuit current making current. As stated in this, the rated short circuit current shall correspond to the rated for 50 hertz based on the tau C. I want to show this you. For a rated frequency of 50 hertz based on the standard time constant, tau is equal to 45 milliseconds. It shall be 2.5 times the. That means in circuit breaker, if you have a circuit breaker 25 breaking capacity, you can when we have to find the making current, we generally multiply by 2.5 times of the our breaking capacity. This 2.5, what is this 2.5? Why it come? It is 1.8 root 2. Whatever we have, 1.81 root 2. This portion. This is when we multiply it, it becomes 2.55. So that means our peak value, the rated peak withstand current is equal to the rated short circuit making current. This current, we peak value of current is equal to the rated short circuit making current. Now, how we this affect this our circuit breaker selection? Have anyone idea about this? How will this affect our circuit breaker selection? See, you can see if our tau is different. I have shown you in this slide. If our tau is 45 milliseconds, then it will be two multiplication of making peak current will be multiplication 2.5. But if our x by tau, that is the time constant, is 120 millisecond or 60 millisecond and 70 millisecond, then what will happen? Our x by r ratio will be changed, and our making current or peak current simultaneously will also change. Now, what we have calculated here, we have taken the 25 kiloamperes of short circuit current, and we have calculated the peak value of short circuit current. For 50 hertz, it is 63.99, and for 60 hertz, it is 65.05 kiloamperes. Okay. Now we will verify these results from ETAB and dig silent for factory. We will put these values. We will put the X by R ratio, and we will put the short circuit current, breaking current of the breaker or breaking. And you will see when we perform the short circuit analysis on the ETAB, you will see, you will get these values. Okay, 1 minute. One minute. I will share. What is happening? I am trying to share, but why it is not getting shared? Actually, it is good. There is some problem in sharing my screen. I do not know what is the problem. I am trying to share, but do not know what is the problem. If it does not share, I will share. 1 minute. I will try from this.